Hey, hi everyone. This is Sai from Let's Upgrade. So let's talk about how to get your certificate. It's very simple. You will see two links in the description. Number one is the place where you have to go and mark your attendance. Marking your attendance tells us, like, okay, you are a legit student who have attended this particular session. Link number two is your assignment. This is where your 90% of the priority is. You have to go and submit the assignment that is given to you in this particular session. Once you're done submitting that assignment, we will be evaluating that. We will send you an email. If you get the passing criteria, then only we will give you the certificate on a particular date that is mentioned again in the description. Please check these three things, and this is the way how you will get a certificate from Let's Upgrade. Number one, mark your attendance. Number two, just go ahead and upload your assignment. Check for the email that you have received it, yes or no. What is the feedback that you have received from your trainer? Number three, check on which date the certificates will be released. Thank you. Bye. All the best. Happy learning.
Hi, welcome to Let's Upgrade. So this is Rajshekhar. I'm a senior data engineer in data analysis. So today we have to discuss about Seaborn. Majorly, a Seaborn is a library, and then using a Seaborn, we have to go through the majorly explaining about the box plots, and for that purpose, we have to explore around the Iris dataset. So, what is this? And as part of workshop, we will go to we are learning the why the box plots are very important and how we will visualize the data using a box plots and how the box plots will help for you to reveal the distribution patterns and statistical insights in the classical areas data set. Okay, so a Seaborn is same like a Matplotlib library, and Matplotlib library also is a visualization library as part of the Python. But a Seaborn is somewhat beautiful than this particular Matplotlib library. It's like a sibling of the Matplotlib library, which is more attractive than the particular what it is called Matplotlib library. So now, as part of this workshop, we will explain you Iris dataset, and we are applying all the our visualizations on top of the Iris dataset, and we will take some insight and patterns using a box plot. And majorly, the box plots are useful for the statistical patterns and statistical insight in the data sets. So let's jump into the box plot. What is the box plot and why, how it will be helpful for you to understand the statistical information about the data. I will explain you in the next step. Yes, now we have to explain about why the black box plots are very important as part of the data science as well as data engineering and data analysis. So this particularly data, this particularly box plots will be helpful for you to telling the story about the statistical information about the data. So if I take it's like a five number summary means we have to visualize the minimum value as part of the data, or median of that particular data, and we have to tell about like what are the how the maximum values in one compact display, and then revealing data concentration and the range. So again, we have to add one more advantage is like we can category comparison as well as part of the box plot, and then we can detect the outliers also using a box plot. That is major. Using a box plot, we can do so much information, or we will get much information compared to other visualizations. Let's quickly jump into one example. I will tell you if you take a students course as the data, in that I am taking a one column that is the test scores. So I want to know about how how people will getting how many people are getting above average, or how many people are getting a below average, how many people are getting maximum marks, then I want to know about a score distribution using this box plot. As he was seeing a box plot, this is the overall 60 to 100 marks. So minimum we have above something minimum there is a marks as in the student, the people are getting like around above 65, something like that. Minimum a student in the classroom, definitely they will get something above 65. And if you take 25 percentage the first quarter, so if you are taking a first quarter, okay, then okay, first quarter, it is nothing but Q1. So what is the first quarter? Quarter, that is nothing but what it is called. So 25 percentage of the students are scored below the what it is called 78, something like that. So, and then what is the median? Median means 50 percentage. 50 percentage of the people in the classroom getting below the something like 82 or something like this. And then what about upper quarter? Upper quarter means 75th percentile. Means 75 percentage of the classroom people getting below the 90 marks. And what of the maximum marks as part of the classroom? That is nothing but 95 above, something in between 98 or something like this. Okay. Oh, that is about the how we will define how we will it will be explaining about how the marks are distributed around the classroom. So now quarter one means 25 for 25th percentile, and quarter two means a 15th percentile, and quarter three means 75th percentile, and then we will get the maximum. Like so, if some people are getting out of these, means it is an outlier. It is unnecessary data. Like it will be a improper data as part of the column. So then we are compare the same other subjects marks also like this, then we will compare the both marks, how the marks are like. Yeah, the next step is to understand the data set. So a classic data set in the data sets, that is like the iris data set introduced by Ronald Fisher in 1936. It is a most famous data sets for the learning a statistic education and as well as machine learning. So now, as part of this data sets, we have a 150 total samples, means totally 150 records as part of the data frame, and then three spices, three species types, that is Setosa, versicolor, and virginica. So this the three spaces as part of the data set, and then four fields that will explain about this particular dimensions of the species, like sepal dimensions and petal dimensions. So each species contain 50 samples with the four numeric features: sepal length, sepal width, petal length, and petal width. Let's preview the data so that you will get some idea about iris data set. Okay, now let's go with this. I have to go to the collab. Already, I think everybody know about the collab. Collab is somewhat online notebook, online Jupyter notebook as part of the provided by the Google company. Google, if you have a Google account, that is enough. You can use and you then go for the collab.research.google.com. Then you go open a notebook and you can experiment, Python code without any setup. So first of all, I have to import the pandas. Let's see. Okay, then I have to. I don't want to type the code here. It will take time, so I have to run this, or otherwise I have to import pandas as PD. So first of all, I have to import the pandas library. Then actually the data will be available as part of some URL. I have to go to this URL. Okay, let's follow the link otherwise. See, the data is not have a schema because we don't have a column names as part of the data. First of all, we have to read the data normally, and then we have to set up the column names for that. For that, I think I will just zoom it. If you have any issues with that, let me know. So then I have to read the data set using a URL. I have already URL. Let's have. I want to define the URL first. So this is my URL. Okay, everybody is seeing, right? This is URL where the data is there. So using pandas, we can read the data from the URL directly. So for that, pd dot read dot csv, read underscore csv, and then we have to go for this URL. So let's keep it. Here is, and then we are also available. So then we can just read it. So it is read it, like I have to give the name for this. Okay, well I have to store this data frame in some Iris df, so I can store this information. But as you're seeing, you don't have any column names as part of the data set, right? So I have to set up the column names using a second argument, that is a column names. So I have to predefine first column names. Okay, let's have a quick jump into the setuping predefined. Explicitly we will pass the schema. For that I have to take column names, that are the column names of the data is something. Let's see, I will explain you. Sepal length, first the column is explaining about sepal length, and next one is the sepal width, and petal length, and petal width, and species, something it's like that. So now I have to pass the argument, so that is column names. So that's it. Now run again. Now, okay, what happened? Column names. Okay, I have to run this first because it is not defined yet. So again I have to run it. So what is the issue with his? Okay, two were given. Like, it is taking only one argument. It is okay. Names is equal to, okay. It is actually a keyword argument. Names equal to. So it will take now. I think so. There is no issues. Syntax error is common. You have to be debug. So that's it. Now it will be ready. If you want to preview the data, then you have to go to Iris and df dot head. So now that's it. Just run it. See, this is the Iris dataset where first column is a sepal length and second column is sepal width and petal length and petal width and species. So some people have a confuse what is sepal, what is petal, like this. Maybe some people are not aware about these things, so that I will explain you what is sepal and what is petal. Sepal means this is the area where is the bottom of that flower, like an thing, that is a sepal, and this is the something is it is a petals. So it is this particular data set will explaining about the this sepal width and so previously we taken the Iris dataset from other URL, right? So as part of Seaborn, actually the Iris dataset is already there as part of the Seaborn library. So we can directly loading the data from the Iris dataset from the particularly a Seaborn. So let's going to go for the Iris dataset from the Seaborn. Okay, first of all, for that I have to import first Seaborn, import Seaborn as a SNS, and then I want some other libraries like import Matplotlib library as a PLT. So I have to import the Matplotlib library as well. Then what about the next library? I want to plot the pandas, and as well as I want to import the numpy as well. So I have to import this three things. I know like this will be helpful for you to visualize the data. So we are imported Seaborn as a SNS, and we imported Matplotlib library as a plot, and then import pandas as a PD, and then we have to import an NumPy as a NumPy. Already I told you that Iris dataset already as part of the Seaborn, so that I just directly loading the dataset from the Seaborn. It is like SNS dot load datasets as part of Seaborn library. It is predefined datasets as part of the Seaborn, so that we are downloading from there. So that is about the Iris dataset we can load from the SNS. Then what is the next one? Like if you want to preview the data, like we can do something. How like we can plot the figure something 8 inches width and 8 inches what it is called height. So can I draw the diagram for this? Okay, and I just run it. It will take the the plot of the plot dimensions, that is 8 inches width and 3 inches length of the particular diagram. So I want to off the axis because I don't require access as part of the plot. So I want to off this. If you on, what will happen, I will show you. Okay, no worries at all, it will off. And I will tell you, don't worry. Then after that I have to make it tight layout for this. Means we don't overlap the edges and everything. So for that purpose I have to make this. Okay, let's see like so what happens. So okay, so for that I have to make the layout, and then we have to preview the data as a table. For that I have to use plt dot table, and then we have to take some iris dataset, iris dataset head. Okay, so then I'm taking the values from there. Okay, there may be a confusion if you are going to the more code at a time, so that I will explain you better way. First we have to take the head values, means five values as part of the data set, and then we have to labeling with the columns, and then we are shifting to the table at the middle, so at the center, like I will show you how we are doing. So see like this. I think all of you seeing this particular thing. So we have a column names. We taken a five values from the iris data set, and then we are setting the column names for that from the iris dot columns, and then we are setting the column as a log is equal to center, like it will be a in a center point. So that is about the how we will plot the table for the preview the data. Then I have to I have to save this as something like a png. For that we have a program that is save figure, and I want to change this to my okay content sample iris preview. Okay, like that I want to save. And box inches is tight means like we don't want to overlap the particularly tables table rows and all columns. We have to make that will be tight. So then we after that, after the saving the file, we have to close the plot. So like that, let we have to see whether it is saved as part of the folder or not. Let minimize the things. So it is saved as part of the so as part of this. So actually you people are seeing the it is the particular preview as saved as part of the folder sample data as a sample data png. So that is about a preview using a Seaborn. I read the iris dataset which will be predefined as part of the Seaborn library. I set up the dimensions for the the table 8 comma 3, and then flat axis is equal to okay. If you have a question about this, I will off and I will tell you what will be happens. Like I will say on. So let's run it. Okay, I think we have to take from here or otherwise. Let's see again if I off the things what will happen from C here. If you off the plot axis is equal to on. So previously we plot axis is equal to off, so that we don't have an axis like x axis y axis. But as we are plotting the table, so that we don't require the x axis and y axis, so that I'm just simply avoid to to avoid the x axis and y axis, I have to keep this in off. So that is our idea. So that is about the previewing the data. Let's have to quickly jump into the plotting the graphs all these things so that you can get a more idea about the box plots. Okay, let's start our first box plot. That is for these sepal lengths of every species. So that we will get a comparison of the every sepal length of every category. Like we have a three categories: Setosa and versicolor and virginica. Maybe my pronunciations be little bit different. I know, like I a little bit have a pronouncing problem, so there is no issue. But I know three categories: Setosa, versicolor, and virginica. This is the three categories. So let's. I will explain you. This is our final output. How we will compare a sepal length of the Setosa, versicolor, and species and virginica. So let's start. First, we have to set up some size of the plot using plot figure, something like this. I will explain you each code, don't worry. I don't want to explain you all these things at a time, because it will be again it will be a very clumsy to understand the things. I know that, like as I feel that I'm also student, and I have to be I have to teach in a simple way, so no worries. So this is a plot size, 10 comma 6. So means 10 10 inches width and 6 inches height. Then we set up some area to plot the graph. So then we will going to next, using a SNS, we are going to plot the box plot. Let's have to copy this. Okay, so then I have to go here, and I have to. I will explain you. No worries at all. So we are going to draw the box plot for the this particular iris data sets. So first we are selecting SNS dot box plot. So it will ask what which data, which on top of which data we have to work. First argument should, you should give a data is equal to iris. On which data frame we are applying the box plot? Iris data set. And then what we are taking x-axis? X-axis is equal to spaces, I mean categories. That is all, like setosa, versicolor, and something like that. Another one is virginica. So now y is equal to sepal length and x is equal to species, and then plat is equal to set 2. Actually, this is something which will be set up the cool colors for the graph, or like something. I will tell you how to change the colors as well. And then line width, whatever the diagram as part of that, particularly this thing, then we are changing the line width as well to look better. The diagram will be look better, or blocks plot look better by using a line width as well. So file our properties, there is a, we have a, that particular outliers, how we will make the outliers and with red colors, and we have to make the size of the outliers as well. So for this is the property where we have to make the outliers, outlier sizes and outliers colors. Okay, let's see. See, this is that is particularly the diagram where we have a set of x. In the x-axis we will taking a species, and y-axis we are taking a sepal length. And then this is the outlier where it is in red color, because already I mentioned as part of the marker is equal to circle shape, and then it will be like something red color, and size is something 6. So let's play with these things. I have to set this one, set up to this one. Then what will be happen? See, some other colors came into the picture. Set 1, then I will go to the play with set 3. See, some pale colors. So it is just have already predefined properties of the colors to the categories as part of the Seaborn library. Then if you want to see this as well, like, or otherwise we have other things also paid, I think. Let's play with us. Okay, then okay, okay, this is not happen. Ancient, there is a one more thing is also there. Let me check this. Oh, okay, no worries at all. Actually, there is a some paste L1 also there for it will work or not, I don't know. L1. So let's play with this. Oh, no worries. So it is just working with the set 1 and set 2, set 3, so that it will be works for the overall this. Okay. So this is the spelling mistake. I have to get S, and then we have to draw the diagram like this, or like one you can go with the set 2. Okay, that is, I'm just playing with the code, guys. You should aware about this thing, because every argument or every key argument as part of the particularly code, it will be definitely helpful for you to understand more into the way. And then width of the line, if you can change to line width 10, what will happen, let's see. So something, it will be big. Oh, it is not appearing good, so I have to be changed again to 2 or 2. It's be like, okay, the line with this something line with this very good, and it is appearing good, and it is very nice to see about the look. And then if you want to change this also, it is possible, but I don't want to change it to some other outlier things. And then if you want to change this to blue, if I want to change this to blue, is it possible? Let's see. As it is, I think it will change to the blue, because previously it is red. The outlier it nowadays be a blue color. So it is a size of the outlier, and you can change it. So as of now, I think like this is the data set what the box plot uses. In the X label we taken as spaces, and Y label we taken as sepal length. And then this is about the visualization. But now what about inside? Inside is something like the categorization. Like let's have to quick jump into the other properties. Then we have to explain you what is inside we taken from this. So let's set up some title and X label and Y label. So for that, we will use plt dot X label, plt dot Y label, and plt dot title. Let's set. Then I have to run again. It will set up something look like this. And then we have to go for the tight layout. I don't want all the things. Let's have a white layout, tight the layout without any disturbance, or cutting the edges. Okay, let's do it. So now see, this is the where we have to get this particularly, all these things. Sepal length by spaces is the title, and sepal length is the Y label, and species is the X label. That is about the diagram. So from here you should observe this. You can just observe, like I want to save this into some other folder. Let's have to save it. Let's save the things. So if you feel bored, no worries, it will be inside. Okay, so let's draw the diagram. So now I have to explain some story behind this. So see guys, we are taking this is in centimeters. Around setosa length of the sepal length in between, so something near to 5, and around 5, like it will take 4.6 or 4.7, 4.8, and something like near to something like up to 5, below 5.5. But if you take a versicolor width, it will be started with above 5.5, and it may be like something. So minimum it will be as part of setosa, it will be minimum is 3 something is there, but maximum is something 6. But you take versicolor, that width, the length of the sepal length of the versicolor will start with the 5 exactly, something near 5. Then maximum the sepal length of the versicolor will be like above 7 as well. So again we will go to Virginica. There is a width will be started with the minimum something 5, and around it will be maximum 8. So luckily we will get some insight, like the sepal width, how the sepal lengths are different from the setosa, versicolor, and Virginica. So this is the beauty of the box plot. We can directly jump into compare the lengths of the each category by using a box plot. We will get a statistical information from that. So that is about the first box plot. It is giving very wonderful information from the first. So horizontal box plots. So previously we see vertical box plot types, right? It is an alternate perspective of view of the vertical plots. So why we go for the horizontal plots means better to long and category names, and if you want to go for the easier to multiple, because people are habituated to see like horizontal graphs mostly. So that I am also looking for the alternatively going for the horizontal box plot, so that people will be very natural left to right reading of the flow, and everything will be flexible as part of the C1 library. So then more space for value labels, and it will be definitely useful for you to more interactive way to see the particular things. Let's have to jump into the minor changes as part of the code, and then we will plot the horizontal box plots. I think you got it the advantage, because it is will be like more friendly to read or more friendly to draw the box plots. So that's what I have to go for the horizontal type of box plot alternatively. So now let's go into the this, and then minor changes as part of the that is orient h. Okay, let's I have to see this, then I have to run it again. So copy the all. I don't want to explain here again, because already knows, if you already people, I already explained in that particular. There is a change in orient. There is one more keyword that I used as part of the horizontal is orient is equal to h. Defaultly it is taking a vertical. If you are putting orient is equal to h, then it will be the orientation will coming to the horizontal way. So that I changed the title, everything is same, only the coloring cool warm, and previously it somewhat different colors, but here it will be like different colors, the cool warm colors, and then orient is equal to h, and then title will be the same horizontal view, that is a vertical view, and it is a horizontal view, and then labels and everything is same. And just I saving the file in the sample data as a sample and preview in the horizontal thing. So let's run it. So see, this is the, so it is somewhat a friendly way, reading left, like left to right, and most of the people are. It is a convenient way to read. This is the advantage of the horizontal box plots. So if you feel that which will be a better, you can comment in the comment box as well. So I feel that horizontal is a better for me to, as I usually prefer the horizontal box plots. Okay, that is good. Then we will go to the next step. So next step is to multi-future comparison using a C1 subplots. So to gain a comprehensive insights, we have to create a grid of box plot showing all the iris measurements like sepal length, petal width, and the petal length and sepal width. Like this are four measurements. We have to create a subplots for this particular things to understand how the data distribution around the different what it is called. How the data is distributed around a box plot. So it will give a good statistical or some insights from that particular information of the iris data set. Let's go with that. Like let's open the collab, and I have to make first of all I have to set up the plots. For that, let's have a plan to do this. So for this purpose, I have to go with this, and I have to set up the futures first. What are the futures as part of the iris dataset? The futures are sepal length and sepal width and petal length and petal width. Let's come up with this first. So I define the futures, and then I have to set up a figure size, and it is a subplots, right? So I have to set up the axis as well. So it will be a subplots 2 comma 2 means 2 rows and 2 columns. So this is will be like I will show you how it will be look like. Okay, let's have this, and just run it. So this is like this subplots. So this is the 00, and this is something 01, and 0001 and 011, and something like this is the how we will using the four plots. four subplots by taking a two rows and two columns as part of the subplots. So that is about how we will set up this particular plots. Now we are ready to create ready to draw the diagrams for this particular things. For that purpose I have to enumerate the futures with the in this particular thing. So we have to loop the things around the particularly subplots. For that purpose I have to use the main loop. That is, the main loop will be used the if you want to see that how it will be like, it will take the zero and the first future, sepal length, or next future one, and something like this. I already I will show you, right? As part of my code, like I already used this. So let's see here. I think I already visualized this, so let I have to explain you better way. Or otherwise, if you want to see that, you can see by just printing the things as well. Okay. So that is will be the main loop counter, which will be go through the every subplot, and it will create the sepal length and sepal width and sepal particular petal length and petal width. And then we have to set up the axis for that particular things. For that we have to go with this. So for that we are using IDXC2 and IDX percentile 2, means it will take first IDX means 0, and 1 means sepal length. It will go to that 0 by 2 means 0, and 0 modulus 2 means 0. So 0 by 0 means like it is going to the that axis, 0 0 comma 0 axis, and it will print, it will go to the species means like what if the species are there as part of that, and we will select the feet. That means like we are selecting the first sepal length or sepal width as part of the y-axis, and then we will select the particularly what it is called color of that, and we have to select the axis. So that is about the how it will be going. So let's understand, then it will show you. See here, it is something like sepal length. It will started with here at 0 comma 0, and then 0 comma 1 and 1 comma 1, and then it is something 1 comma 0, like this. So we have a axis like this, and that axis will be looking like, and it will plotting the subplots for the every separate category. So I think may few people are complex to understand, please set up a proper particularly run the each code and then understand. That will be good to understand the plots as well as part of the Seaborn. Okay, then we have to set up the title for this. Set title. How we will set the title? It will go to the 0 and 1 means sepal length, and from that there may be a column as part of the underscore. It will replace the underscore, and it will just print the that particular without the underscores. It will give up with the spaces, and then we will set up the title for that particular thing. Then we have to give a X label, and we don't want any X label, then it will just remove the underscores, and we have to put a space. Then Y label, we are taking a feet, and then we go in with the first one, then that will be a title as part of the title. And then we have to put in a CM, so that what will happen, sepal length, and then it will go into the particularly what will happen. It will be just for the, see here, like petal and sepal in centimeters and sepal in centimeters. So like then we are not using length or width or whatever maybe. It will just remove that, and we have to put in adding something centimeters to that particular as part of the Y label. So that is about this code, and we are avoiding the overlap of the edges, so that we are putting plot dot tight layout. So once you run, the subplots are ready. So it is a very wonderful, beautiful subplots as part of the things. Can I zoom it little bit so that you can get? more into this. So this is about the petal, sepal length, and this is about the sepal width, and this is about the petal width and petal length. This is how it will be like, multi futures at a time using a box plot. Let's see what the insights we are taking from here, and see, we can easily observe how the data will be, how the length and how the width variated, or how it will be distributed around the different sizes in centimeters. So that is about the multi future things. So it will give more insights. It's like, petal measurements are like length and width show that most dramatic differences between species with minimal overlap, and setosa petals are distinctly smaller. So if you see that, let's setosa, you can see setosa are very small dimensions, even it is a petal, or even it is a something like whatever, maybe it is petal or petal, or it will be a length of the petal, or particularly sepal width or sepal length or petal length or petal width, compared to all these things, majorly that setosa length and widths are very small. So that is one more insights, and then we have to distinguish this mark, making easily separable from the other two species easily. And what about sepal width? Unlike other features, sepal width shows the substantial overlap across the species, particularly between vascular and vagina, make it weaker classifier its own, like something overlapping because of the this particular what it is called vaginica and vascular are overlapping in between these particular things. So we cannot that much variated from the other things. Both are the weaker classifier and its own. And then what about outlier parts? Several outliers appear across the features, particularly in sepal width and for the setosa. And data points warrant closer examination, but won't necessarily indicate errors. So that's what, like, I will go here, and you can see there is a lot of in the setosa and the virginica we have seen outliers. So here outlier and here also outlier. So this is about the information about all the outliers, and as part of the how the data is distributed around the particular things. So box plots are very beautiful to get some insights easily by just seeing the subplots, and as well as comparison the characters categories. So that is about the box plots. If you have any question in the middle, then I will explain you again. We are set up in the futures, and we have to we have to plotting the 2 by 2 means 2 rows and 2 columns of plots, and then size is 14 comma 10. Then we are looping counter and enumerating with the futures, so we can get every axis size, and then we are fitting the box plot using a looping around every species, and we are plotting the graph for every category, and we are replacing the underscores with space, and we are setting the titles and x labels and y labels, and then we are putting a particularly subplots for this particular thing, so that we will get these insights. So the insights are petal measurements are strong discriminators, and sepal width are the exception case, and outline patterns for the futures, particularly in sepal width for the setosa. This is somewhat majorly that we are observed as part of the subplots. These are all the what it is called. We will call it is the insights from the total data set. So, okay, guys, if you have any questions as part of the insights or any code, you can comment in the comment box. We'll go to the next step as part of the as particular workshop. The next step is to recap all the things what we learn as part of the workshop now. So, guys, like first we have to import the data from the existing data set from the Seaborn. So we imported as a required libraries, and then we loaded the iris data set, and we have to preview the data as part of the first step. Then we will went to the first diagram, that is our first insight, that we are using a box plot. We created a first box plot by sepal length by spices. So that will look like this, and okay, then this is about how it will be look like this. So then we are getting next one is something we have to go for the horizontal view, where horizontal view will be very friendly view for the who are regularly using a box plots, or everyone very good about to see horizontal views, so that alternately we will go for the horizontal box plots as well. It will be a good advantage for the regular users. And then we went for the horizontal views, and then we went for the some subplots. So that is the multi future view. That is how we will compare the categories of categories, like how the sepal length was data distributed across using the different spices, and how sepal width will be distributed around the different categories, and how petal length will be distributed around the different categories, and how the petal width also distributed around the different categories. Like this we will compare the every category by using the multi future. And this is about the how we will use the subplots, and we will create that. This is about the next step. Then we are done with this all those things. It will be very useful for you guys to go with the particularly a box plot. A box plot is a beautiful visualizations to get the information. Thank you everyone. We you people are spending so much time to invest on the particularly box plots, and definitely it will be very useful for you guys to go with the get the statistical information and comparing the categories on around different categories. And then moreover it will be the five number summary. Five number summary means like we will get the how much percentile of the people are in under first quartile, and how many people are below the second quartile, and how much the data will be below the third quartile. Like this we are getting a five number summary as well as part of the box plot. So this is about the how beautifulness of the particularly box plot. So can I get like last summary of this particular thing? So the thing is, as part of this workshop we are getting take away mastering a box plot using a Seaborn. A Seaborn is a beautiful library that will be helpful for you to get more advanced visualizations. And box plots reveal a distribution pattern instantly. And the first thing is it is a five number summary. And then iris dataset demonstrate clear spices separation. We taken up petal measurements provide the strongest discriminate features. That is our insight. Whenever you are seeing like these petal measurements are provide the strongest discriminant features, while sepal width show more overlap across the spaces. So we are seeing all those things as part of the our workshop today. Already we seen already all the insights as of we are seeing already we completed the insights. And then Seaborn simplify the complex visualizations with just a few lines of code and create a public quality plots that effectively communicate the statistical relationship and distributions across the different categories of these spices. So that is about the workshop. Once again, thank you everyone. You people are invested the time, and you people are get some idea about a Seaborn. You are now mastered in the Seaborn library. So guys, as we are going to conduct a series of data science workshops, and that will be helpful for you to develop your skills in the data science. So in the next workshops also we will go with the series of the data science workshops. And then we definitely you can comment on the comment box. And if you there any issues in the plot, or if you were seeing any mistake in my delivery, then definitely comment in the comment box, because we are humans. Definitely we have we are in mistake in some areas. And then definitely we will take the feedback from you guys, and we will improve, and we have to deliver such a content which will be useful for everyone. So once again, thank you everyone. I know bye all of you. We are seeing the next workshop.